David Smith here with one more Flip Classroom math video. 3 tips before you start. First, you could speed up or slow down the playback if that helps you get through the video at your own pace. Second, you could pause the video at any time to catch up with your notes. Third, you could turn on the captions and watch my words go by on the bottom of your screen. Today's topic covers the surface areas of geometric solids, and it's the last new lesson in our series dealing with geometric solids. So let's take a look. We're going to start with prisms. Okay, and if you recall, a prism is a figure built on 2 bases, like a base and a top, that are like a polygon, triangle, square, rectangle, etc. And then it has rectangular faces that go around that connect the 2 bases. So what you do for a prism is you just add up the areas of the bases and the faces. So I've got that definition, there are those instructions, and then we're going to do one of these problems right there. So let's get started. Okay, so we need to add up all of the areas in this rectangular prism. And these problems are a little bit tricky because you have to keep track of what you've added in. Some of the later figures have much more simple plug-in type formulas for finding surface area, which is great, but this one does not. So we need to actually figure out what all the faces are. And actually there's a thing about it that helps us save a little time. So I like to do the bases first. So my bases, I have 11 times 5 for the bottom base, and I have 11 times 5 for the top. So what I have is I have 2 times 11 times 5 meters. So that's going to give me the area of my bases. Now I have my rectangular faces going around. And so I have this front face is 6 by 11, but it's the same as the back face. So we're going to add 2 times 6 times 11. So that took care of the front and the back face. And now we have our 2 side faces, this one and that one, and we have 2 of those, they're the same. So we're going to do 2 times 6 times 5. So here we go, we've got all 3 faces. Now we just have to do the calc and add this all up. Now I love to factor, so notice how we have a 2 times all of these. So we can write 2 times 11 times 5 plus 6 times 11 plus 6 times 5. And that might give us a little bit of a quicker step there. So go ahead and pause the video and see what you get. All right, when I do my math on that, I get 302 square meters. Now remember, the last lesson we did volume, so we had cubic units. Now we're back to area, so remember your units are squared. All right, let's try a triangular prism. A little different, and we're going to need to do little calculations inside the diagram to get some of the heights we need to calculate area. So first off, I'd like to start with the bases. So let's check that out. The bases here are triangles. So you've got to know that the formula for the area of a triangle, to be able to do that, use that area formula, which is area equals 1/2 base times the height. That's the standard area formula for a triangle. And see if you can apply that to the bases. We have 2 of them, front and back. And notice how what I've told you here is that it's a triangular prism with isosceles triangle bases. And so those are marked here. That side equals that side. That's going to come into play a little later. But right now, write an expression for the area of the bases. All right, let's see how you did. The area is 1/2 base times height. So 1/2 base, which is 10, times the height, which is 4. And we have 2 of them. So I put 2 times 1/2 times base times height. So that is the area of our 2 bases. Now we need to figure out the area of the 3 rectangular sides. And this is a little more complicated. We do know that one dimension is 15. So that's good. We're halfway there. But we need another dimension. We need to know this slant height for the triangular base, or this side of the triangle. So go ahead and pause the video and see if you can create a side diagram that'll help you calculate that length. And I'm going to give you a hint. It's based on this little triangle right there. Okay, so check this out. I know that with an isosceles triangle, the height is going to split the base in half. So I took this little diagram, this little triangle right there, and I have my height, that's this one, and this piece of the base is 5. Okay, so this is something you just have to know about isosceles triangles. There's a whole lot of nice things if you know that two sides are equal. You also know that the two base angles are equal, and like we just did, you know that the height of that triangle splits the base in half. So I've got a 4, 5, who knows what that C is? Right triangle. Okay, go ahead and write an equation and find C. All right, let's see how you did. Here's my equation. 4 squared plus 5 squared equals my C squared. So I wrote that out. I solved that for C. C is just the square root of 4 squared plus 5 squared, which is root 41, which is approximately 6.40. So then I went ahead and put that on my diagram for the slant height of the triangular base. Okay, so now I want you to pause the video and write an equation to calculate the surface area of our 3 faces, our three rectangular faces. Okay, I put my work there, but before we go into that, I want to remind you that understanding this isosceles triangle is crucial to solving this problem. So we figured out that that slant height was 6.40. That gives us another slant height that we're going to need. Remember, isosceles means 2 equal sides. 2 equal sides. So if this side is 6.4, so is that side. And that's going to be crucial here. So now we need to calculate the area of this rectangular face, the one on the front, the one in the back behind there, and then the one on the bottom. So the one on the front, 6.4, that's the slant height, times 15, that's that rectangle, boom. The one on the back that we can't see is the same, it's identical. It's 6.4 times 15, and then the bottom one is a rectangle that's 10 by 15. So there's my plug-in step for the calc. Go ahead, pause the video, do your calculation on that. Let's see what you got. All right, when I do the crunch the numbers there, I got 342 meters squared. This one here, that's going to be 1/2 times 4 is 2. 2 times 10 is 20. Times 2 is 40. So that's 40. So the total surface area is going to be 40 plus 342, which is 382 meters squared. All right, let's do a surface area calculation for a pyramid. So let's first talk about what that means. Pyramids have one polygonal base. So it could be a square pyramid, that means it has a square base. Rectangular pyramid, which is our example. It could be a hexagonal pyramid. It just depends on what the base is. So it's got a polygonal base. The sides are all isosceles triangles. In our examples, we're going to keep that way. We can add complexity by not requiring they be isosceles triangles, but that makes the calculation more challenging. So to find surface area, you just add the base and all the faces together, okay? But before we do that, I want to go ahead and review a little bit more of an isosceles triangle just to make sure you have all the details. So there's your basic isosceles triangle, 2 equal sides. But that allows you to say a bunch of stuff. So the 2 tick marks means those 2 sides are the same. The angles opposite the sides are also equal, okay? So if this angle is 50 degrees, so is that one. Now the last thing, which we explored in our last problem, was that the height of this triangle, a vertical, splits this 2 side into the same length. So I could write x, because if this side is x, so is that side. So all that stuff is useful in figuring out surface area problems. All right, so let's take a look at this one here. I've got a rectangular pyramid. How do I know? My base is 10 meters by 8 meters. So that's what tells me this is a rectangular pyramid. My faces have slant heights of 12 meters. So that, if we just break out this little triangle here, that triangle has a height of 12 and a base of 10. So we can use our triangle area formula to calculate that area quite easily. So let's take a look. This one should go fairly quickly. We're going to start with the base. And what's the area of the base? Pretty straightforward, 10 times 8. So the area of the base is 10 times 8, which equals 80 meters squared. So now we have our base area. Now let's take a look at our face area. Now this is interesting. We have two sets of identical faces. The front face is got a height of 12 and a base of 10, and that's the same for the back face. So we have, so let's do the faces. Here we go. Faces. The front face is going to be 1/2 times the height, which is 12, times the base, which is 10. And we've got 2 of those. So there we go. So I've got my front and my back face. Now my side faces are going to be in a similar way. It's two. We have two identical ones. We have this one and the one on the back there. And that's going to be 1/2 times 13 times 8. So we have 2 times 1/2 times 13 times 8. So go ahead and pause the video and do that calculation. All right, I just took this calculation all the way home. So first off, the surface area of our faces, if you do this math out, you're going to get 224 meters squared. Add that to the 80 for the base, and I get 304 meters squared for the surface area of this rectangular prism. All right, let's take a look at a cylinder. Now we're getting to the place where we have straight up plug-in type formulas for calculating surface area. So let's check this out. A cylinder, again, surface area of the base, that would be bases. There's 2 bases for a cylinder, and the curved surface face. So what we're talking about is we have these 2 circle bases, and then we have this curved surface that's wrapped around. Now that curved surface can be unwound, and it's basically just a rectangle with the height being the height of the cylinder, and the width of that rectangle is your 2 pi r, your circumference of the circle, and that will show up in our formula. So here we go, here's a formula. Surface area equals 2 pi r squared. That's the area of the base, but times 2 because we have 2 bases. So that takes care of the base area, and then 2 pi r h is 2 pi r is the circumference of the circle, which is, if this is unrolled out, it's just the width of the rectangle times h, which would be the height of that rectangle. So there's that formula. I like my formulas more concise. I know the IB doesn't put it this way, but the way I would do this is it's 2 pi r times r plus h. That's a little bit more simple. That gives you exactly this formula, but now we've factored out the 2 pi r because that's the same. Okay, so here we go. Here's one. I'm not going to do this one. I want you to just do that. So do your plug-in step. You can use this version or that version. Calculate it, get all the way to the end, find your surface area of the cylinder, and then start the video and see how you did. All right, so I did my plug-in step using my preferred version. Don't worry, you can use that one if you like as well. And I get 5130 meters squared. Now I actually got 5127, but remember IB is 3 sig figs, so you got to round that 27 up to 30. All right, let's do some cones. So a cone, surface area is just the area of the base, one base on a cone, like that, and the curved face. So this curved face that's wrapped around. So this area has a pretty straightforward plug-in formula. It's just pi r squared plus pi r L. So pi r squared is the area of the base, pi r L is the area of this curved face. So let's do a plug-in. Here we go. We've got a cone with a radius of 5 centimeters and a slant height of 14.1. I just want to remind you, L is the slant height in that cone. Not the height going straight down, but the height going from the tip to the outer edge. Okay? So go ahead, pause the video, do your plug-in step, solve, and find your surface area for that cone. All right, let's see how you did. Here's my plug-in using my formula. Pi r squared, 5 is my r, plus pi r L, slant height is L, pi times 5 radius times 14.1 slant height. And when I crunch those numbers, I get 300 centimeters. Now remember, for a calculation that's this simple, the IB is going to throw you curveballs. So they might give you the surface area and ask you to find the slant height, which you should be able to do. They might give you the surface area, ask you to find the slant height, then ask you to find the height of the cone, the real height. So just be ready for these formulas that are pretty simple to get some curveballs. One last figure, the most simple, spheres. If you remember from a previous lesson, a sphere has one number that describes it, its radius. Everything else flows from that. There's no other number that you need to describe a sphere. So a sphere, it's just going to be the area of the curved surface. So whatever that area is of the outside of the sphere, whether it's a basketball or the earth, the radius describes it, and the surface area is the outside shot. Okay, formula, super straightforward. Surface area is just 4 pi r squared. Simple, simple, simple. So, but I'm going to make this problem a little bit more complicated. Here's the earth. The radius of the Earth is 6,370 kilometers, approximately. I want you to find the surface area in meters and express that answer in scientific notation. If you're feeling bold, pause the video right now and take that calc all the way through. All right, I want to tease out these two steps and give you a little bit of a tip. If you're calculating area and you're converting one of the numbers that you're using, like maybe length times width, or in this case, our radius, you want to do the conversion first and then plug into the formula. So my first step here was to take my 6,370 kilometers and turn that into meters. So we have 637 with 4 zeros. Remember, there's 1,000 meters in a kilometer. Now I did my plug-in step with my formula. So it's going to be 4 pi r squared. Now this number squared is going to get ginormous. Depending on the calculator you're using, it might just go right into scientific notation at that point. Then you don't need to do the conversion, but you do need to know how to understand what your calculator shows. And a lot of people struggle with it when it shows that. So go ahead and do that calculation. Let's see what you get. All right, when I do this on my scientific calculator, when I do that calculation, here's what the readout shows. Well, it's actually 5.099, so it rounds up to 5.10, 3 sig figs. And then I get this E, and then I get this 14. What does that mean? What it means is 5.10 times 10 to the 14. Let's not forget our units, meters squared. So if this was the instruction, the answer would look like that, okay? If you have the fancy schmancy calculator, it will show a lot more zeros. Now you can count the zeros to convert to scientific notation, but I believe the calculator has a feature where you could just say, take this big long number and make it scientific notation. Now that you've watched the video, take a moment to jot down any remaining questions so you can ask them in our next class. If you want, you can come back and watch the whole video again if that helps deepen your understanding. If you enjoyed the video, please click like or subscribe.